Hello there! Today we're going to do the Maths Quest 2012, Maths B Chapter 8, AE Question 1. Yep, let's get right into it. So question 1 states, if f dash x is equal to 2 minus x or bracket square, and the y-intercept of f of x is 4/3, find the rules for f of x. So obviously we are given a derivative and we are looking for the original function. Alright, so let's write out the derivative. Now please remember, f dash x has the same meaning of dy dx. Alright, do not forget about that. They're the same. So dy dx is equal to, we've got the function here, square. Right, and now we have to find, we're given a y-intercept here, right, which is the c in the original function. So we're going to leave it like that right now. We're not going to use it now. The first thing is we're going to derive, we're going to integrate the function first. So integrating dy dx is literally just doing this. So we move the dx over to the other side, which becomes integrate 2 minus x square with the x with respect to the x. So that's how this derivative becomes. So the x move over to that side, and because something over something, when you want to move the delta x over to the other side, you multiply by delta x. So this dot just means multiplication. So everything's fine. All right, let's start integrating. Why am I keep saying deriving? Okay, so integrating a constant with respect to a variable, which give us y. All right. We can, some of you see, remember, whenever you integrate something, we always have a plus c somewhere. But in this case, we don't put it out right now. We put it out at the end. Because when you move the constant from left to right, it's at the end it's going to become a constant. So let's just keep it as a constant. Keep it as a constant right out at the end. So let's wrap it out for now. And it's equal to 2 minus x squared dx. Now to integrate, oops, I made a mistake there. To integrate a something like this, we have a rules, right? We have a rules. So it's just like differentiating this, differentiating a chain, differentiating something like this. We use the chain rule, but so when we come to integrate, we reverse the chain rules. So how we do it is we first increase the power by 1, right? And then we divide it by the 3. The new power, and we multiply by the derivative of the inside. Now the derivative of the inside is what I mean here. The derivative of this is -1, right? So remember that we have to do that at the end. So we have to do that times -1, and then that's is equal to y. So we keep going. So therefore, y is equal to 2 minus x to the power of 3 over 3, and then we put the negative sign in front. Now this negative sign can go up to the top, it can go to the bottom, doesn't really matter, as long as it is a negative. And now this is where we can put the plus c at the end. Always, just, it's for convenience sake, or for less confusion sake, always put the plus c at the end. Not during the middle, when you integrate the y and then integrate the x, don't have too many c's everywhere. All right, but we haven't finished yet. Now, every time when we integrate a function, we get a c. And now, having a c in your original or integrated function does not represent a perfect function. So we have to somehow, if we're given information, we have to solve for c. Remember earlier, we are given that when f of x has a y-intercept of 4/3. So if we go down there, now what y-intercept at y-intercept what's our x value? Right, x value would be 0. X equal to 0. Right, so now, and the y coordinate is 4/3 as given. So we're substituting the values. Right, so our function becomes 4/3, and then equal to -2 minus 0 to the power of 3/3 plus c. Right now, we only got one unknown in the equation, so we can solve for c. So let's not do anything to this side first. And 2 minus 0, 2 plus c. Yep, so what we do next is, now this bit is where you have to be careful. So 2 have to be cubed first, then multiplied by -1 on the outside the bracket. So it would be, so the 2 cube would be 8. Right, yeah, and then multiplied by -3 plus c. So now all we have to do is just move this bit, the -8/3 to the other side. When it's a negative, when you move it to the other side, it becomes positive. This is 4/3 plus 8/3 equal c. Yep, and then, well, this is the same base, so we can same the numerator, so we can just plus them together. This becomes 12/3 equals c, and 12 divided by 3 is 4. 4 is equal to c. So at the end, our function. So remember, our question is find the rules for f of x, which is the full equation for the original function. So we go, therefore f of x is equal to what's the equation again? Okay, so it was -2 minus x cubed all over 3 plus is 4, and there is the answer for that question 1. All right, let's move on to question 2. All right, here comes question 2. Now, the question 2 state if dy dx is equal to 1 minus 4 cosine bracket 2x bracket, and the y-intercept is 2. Find the exact value of y when x is equal to pi/12. All right, so just like last time, we are given a derivative function, which is that, and then we are given another piece of information, which is a y-intercept is equal to 2. Now the y-intercept, remember, y-intercept has an x coordinate of 0, and since it tells you the y-intercept is 2, then the y value would be 2. Alright, so find the exact value of y. For that, first you need y, and then you have to sub in x as pi/12, sorry, to find out what the value is. So first we have to figure out y. So obviously we have to do integration. So dy dx, let's write down the functions, is equal to 1 minus 4 cos 2x. Now the reason why I put a bracket around here is just a personal habit. I want to treat it as a habit inside because I don't want to bring the things out. Now I don't want to treat it as cos multiplied by 2x. There's no such things. Alright, so remember, to integrate, we move the dx to the other side, so it becomes 1 integrate with respect to y is equal to integrate 1 minus 4 cos bracket 2x integrate with respect to x, right? So just like last time, this side is a constant. It becomes whatever that value that letter is over here. It just becomes y, which is what we want, right? So now here we got 1 minus 4 cosine 2 bracket 2x. Now I want you to see this as a bracket in there, and this integration signs is gonna be distributed within the bracket. So you can literally write as this. Oh, you don't need the bracket out there. For cos 2x dx. So you can literally write like that, and then you separate them into two parts of integration, and then you do it one by one. Right? So y is equal to, now you're integrating a constant with respect to x, so you just become x. Yeah. All right. Remember this minus sign here, very important. Now, when we integrate 4 cosine, we can take the 4 out, which is a constant, yeah, and just integrate cosine 2x. Okay, so let's keep going. So y is equal to x minus 4. Now, the integral of cosine is sine, right? So it just becomes sine 2x. Now, when you differentiate sine 2x, remember, you don't just simply change the sine to cosine, you also multiply by the derivative of the inside. So now you have to divide by the derivative of inside, which is 2x, and then we have to divide by 2, which is the derivative of the inside, right? And that's put a bracket out there, and that's it. Once we finish with it, we can put a plus c at the end. So just to keep things tidy up, we can expand the 4 into the function, or into this bracket. So give us 4 over 2. 4 over 2 is just 2, right? So this is minus 2 sine 2x plus c. All right, we come to a stage where we have a original function, but still we've got one unknown, which is c. So we have to use the values that we are given, the information we are given before, which is the y-intercept, to help us to solve for c. All right, so let's go back there. Our y-intercept is 0, 2. So in here, we have to sub in the y-intercept coordinate. So we get 2 equal to 0 minus 2 sine 2 times 0 plus c. All right, now 2, just 2 here. Now 0, I'm just gonna take it away. It's not gonna do anything, so just 0. So it's just negative 2 sine 2 times 0 is 0 plus c. Now, when you get to this stage, you have to ask yourself, what is sine 0? Now, sine 0, how I remember it is, you can use the unit circle way. Sine always represent the y value. Now, we started here, which is 0 degree. So here, remember our coordinate of this point is 1, 0, x and y, and our y value is 0. So therefore, sine 0 is 0. Or you can use another way to remember it, to visualize it, is your sine curve. All right, so that's your perfect, usual sine curve. So it's 0 here, 180 here, which is 360 here. So in between will be 270 and 90, respectively. And right at the beginning, we have 0. Sine 0 is 0. So that tells you, this one also tells you sine 0 is equal to 0. So right now we know. So we can put it in there. Negative 2, that becomes 0. Alright, this is multiply sign in between, plus c. And negative 2 times 0 is 0. So 2 is equal to c. right? So therefore, our real function, our original function would be y equal to -2 sine 2x plus 2. Right now, so with this complete original equation, we can finally answer the question. Remember, we haven't finished yet. The question is, find the exact value of y when x is equal to pi over 12. So now we just have to sub those coordinates in. Right? So the thing is, find y when x is equal to pi over 12. So all we have to do is just put it in. So y is equal to -2 sine 2 times pi over 12 plus 2. Well, that would become 2 sine 2 pi over 12 plus 2. Right? And then you can simplify out the 2 pi. We get pi over 6 plus 2. Right, now, what is sine pi over 6? Well, lucky this is a nice angle. We can use one of the two special triangles to work it out. So we got the first triangle, which is 1, 1, root 2. Both angle will be 45 degrees. Well, 45 degrees is pi on 4. So we don't need that one because we're looking for pi over 6. Alright, so we should construct another special triangle. Now this one's a bit tricky. I remember this is 2, this must be root 3, and this must be 1. And the angle on the bottom is 60 and 30. Now 30 is pi over 6, and 60 is just pi over 3. So we can use the pi over 6 here. This is what we want. So sine of this angle would be opposite over hypotenuse, which would be 1 over 2. So therefore, sine pi over 6 is equal to 1 over 2. Right? Just to make sure it's opposite over hypotenuse. So that's why we get 1 over 2. Alright, knowing that, we can bring it back into the equation. So therefore, y equal to -2 sine. Oh, sorry, no more sine anymore. We already solved that. So 2 multiplied by 1/2 plus 2. Now, remember our BOMDAS. Alright, multiplication comes first. So -2 times half would give us -1 plus 2. So y would give us 1. So the exact value, or when x is equal to pi over 2, pi over 12, would be 1. That's it. Hold on a minute. This is the future me speaking. I just realized I made a mistake on question 2 here a couple days later. But you know, the good thing about doing a video is I can edit the videos. So the mistake I have on this particular question was I forgot about the x in front of the -2 sign here. So this is x here. I forgot about this, and I completely ignore it when I try to find out the y value. But the mistake is not too big. All we have to do is just plus the x back, and that's it. And the x, remember, the x is just pi over 12. Right, because that's what we subbed it into when x is equal to pi over 12. So therefore, the actual value, the exact value of y is equal to 1 plus pi over 12. So therefore, the exact value of y is 1 plus pi over 12. Okay, alright, sorry about that, guys. Hey, but at least I caught on my mistake. At least I try to make it better for you guys by correcting the mistake. Okay, so please forgive me, and I hand you back to the past me. Well, I don't know about you, I'm getting a bit tired and thirsty for all this speaking. So let's go into a commercial break, and then we come back with question 3.